Hello, good afternoon. My name is Milena Megalina, and today I'm going to present the evidence number 2 of establishing patterns and relationships and correlations between variables. First, the exploratory analysis. Here is where we make the correlation, so we can see the correlation matrix of the relationship between the different variables. So here we can observe the coefficients got from the regression that I made from first instance, as well as the coefficients that we got from the correlation matrix. After performing a regression analysis for determining the quality of sleep-based regression model, we can see that the most correlated variables are sleep duration, stress level, and heart rate, which may make it difficult to perform a stable model because they are closest values to -1 or 1. In this case, the closest value to -1 indicates a negative relation, and the closest value to 1 a positive relation, and the closest value to 0 is almost no relation or very big relation. In the next slide, I include the correlation matrix, so we can see how the coefficients that we see on the right picture work. So the ones that are more linear are the ones that have a bigger coefficient. Variable correlation. Here we determine the strongest positive correlation, the strongest negative correlation, and the weakest or no correlation at all variable. Variable correlation. First, we have the strong positive correlation, which is sleep duration and quality of sleep, having a correlation coefficient of 0.883 in. So this correlation coefficient is greater than 0.7 and is very near 1, which means that the greater the sleep duration, the greater the quality of sleep. Then, the strong negative correlation can be the quality of sleep and stress level, having a correlation coefficient of -0.899, meaning that the greater the stress level, the lower the quality of sleep. And weak or no correlation, maybe daily steps in each that have near no correlation at all, having a correlation coefficient of 0.058, meaning that they are poorly correlated. Then, I included the two frequency tables. Previously, I only did two regression models, but now I could do the frequency tables, where the categorical variables are sleep disorder and gender. The relationship interpretation based on the null hypothesis, we got that the p-value is smaller than 0.05, which means the null hypothesis is rejected, which means the result is statistically relevant. The correlation coefficient, we can get it with Cramer's measure of association as 0.145, so the value of the relation between them is relatively weak because the value is closer to 0. Then the second frequency table, we got categorical values that are sleep disorder and BMI category. The relationship interpretation based on the null hypothesis, we also got that the p-value is smaller than 0.05, which means the null hypothesis is rejected, which means the result is statistically relevant. The correlation coefficient, or the Cramer's measure of association, is 0.33. The value of this relation is relatively weak because it's closer to 0, but a little stronger than the last comparison. Then building a regression model. There I built a regression model where we got the response variable is quality of sleep, and it's appropriate because it provides a good R2 prediction based on the values of the rest of the variables. Finally, two additional variables that I would like to include is the sleep duration and stress level, because many other variables can respond to this. For example, the sleep duration variable is related to the quality of sleep because they have a positive relation. On the other hand, stress level is related to sleep duration and sleep quality because the less stress level a person has, the greater the sleep duration and the sleep quality is going to be. So that is it. Thank you very much.